I shared with you that we took some time to develop an implementation of this. And I'm talking with you about end-to-end Agile. What is it to have full agility? Well, I'll show you a way that we put together something that works, that's simple to put together. So this is not pie in the sky. I'll show you what the tools are that we used, how we define some workflows for implementing those tools, how we use specific keys in order to integrate those tools together, and how those keys enabled the code to move through the continuous delivery pipeline. And then I'll show you the anatomy of a specific service that we delivered through this pipeline. And we'll show you how the pipeline was broken down into specific stages that had specific actions done in the specific stages. And we'll show you how we were able to define the infrastructure as code, so we're able to just spin up the infrastructure. And then there's orchestration, creation of containers and orchestration of containers, and we'll show you those. And each one of these is going to have a slide. So in section 10 here, we've got 7 slides. So the tools we used Confluence for knowledge management, we used Jira as the issue tracker, we used Bitbucket as the code repository, we created a pipeline with Jenkins, then we created containers using Docker, and we orchestrated them using Docker Swarm. And we created the cloud resources using Terraform. We configured those resources using Chef, and we used AWS as our cloud provider. So to accomplish this, we created workflows for project planning, for work assignment, and for issue resolution using continuous delivery. And in the project planning, we started with our requirements pages in Confluence, which enable you to integrate with Jira. And this involved a process of creating a Jira Epic feature from within Confluence. Then we created a Bitbucket branch for the Epic feature from within Jira so that they're integrated together. And this caused the Jenkins, the way we had it configured, we used a multi-branch project in Jenkins with their Blue Ocean interface that automatically created the branch in Jenkins when the branch was created in Bitbucket. And that was our process for creating our epics. And then once the epics were created, we created issues within that requirements page. So each one of our epics had a requirements page in Confluence. We were able to brainstorm and have the business level discussion about what the issue should be because it was in the knowledge management tool, not in the issue tracker. Then from within that page in Confluence, we created all the issues in Jira, and then we associated each issue with an epic in Jira. We assigned the work, and that triggered the creation of a Bitbucket branch for the issue within Jira, which auto-created a branch in the Jenkins multi-branch project because we set that up to integrate. Then the developer checks out the code, makes some changes. Developer pushes the code to the Bitbucket issue branch. The Jenkins project branch automatically runs once code is added to Bitbucket because that integration comes out of the box if you know how to configure it. Jenkins automates that. An image was delivered to the Docker repository, and then Jenkins is able to deliver to staging and production. And these are the workflows that we used. So then, how do you get these systems to talk to each other? Well, they don't. You have to configure them to. But it's actually not that hard. You have your issue tracker, your code repository, your Jenkins Blue Ocean multi-branch project, and your Docker registry. These different tools have to talk with each other. Well, we had the structure of our project set up in a way that the branching is going to mirror the structure of the projects because it's this common shared structure I showed you before. So our code repository's got master. When we link these things, we create a master branch to code repository. It automatically creates the master branch of the Jenkins multi-branch project. When we then go into our issue tracker and create our epic, we're able to create our epic in the code repository from within the issue tracker, this triggers auto creation of another related branch in Jenkins so that that works. Same thing happens for one issue and then for another issue. So how do we get all this to talk together? It's straightforward up to this point, because what we've done here is we've gone through the first few stages and we finished merging up to master, running all these tests, and now we're ready to move into staging. Now we're going to move from our code being in our code repository with all this fancy integration and somehow move it into containers in Docker that have to have names and be able to talk to this. Well, it was actually very straightforward to do this. We came up with a name for each one of these images in the Docker registry by linking together three different things. The name of the code repository, and then the name of the branch, right? We've got these various branches. And then the commit hash, because every one of these branches has multiple different commits that have been made to it. Every time a developer makes a change, they push code back into it, and the code repository, what it does is this is our branch, but this is this version of the branch, and another next version, and each one of these is called a commit, and each one of these commits has a key to it, and we took the key or hash for that commit and linked these three things together, and now we've got a name in our Docker repository that matches all this stuff. So we're able to track from this issue, which ultimately is often our knowledge management tool, and go all the way to production and be able to see the path it took and where it came from. This gives us the sense that we're able to go backwards with our diagnostics later because we've got this key that we created. So we somehow need to move through the pipeline, and the way that we did that in our implementation, because this stuff's not built into Jenkins, is we use these keys as ways to, if we know the name of the branch that it's from, we're able to find the parent, essentially. And by knowing the parent, then we're able to climb up. So we're looking at this, and I'm going to make this easier here by putting a few things out. Code is checked into the code repository at the issue level. This triggers this Jenkins branch of this multi-branch project to run. The Jenkins file is basically code. And when you're using Jenkins, your pipeline is broken down into code. Just like when you're using Terraform, your infrastructure is broken down into code. So Jenkins file is the name of the file where your pipeline is defined, and you've checked in code, and the Jenkins file does some stuff. After it does some stuff, and you're at the issue level, you know the issue level, so it's enabling it to go back and query the parent, the name of the parent. You remember we started out in Confluence, we created an epic, and we created that epic in Jira, and then we created issues within that, and we created that relationship between the issues and the epic. Well, that migrated right into Bitbucket, or if you've got a plugin in another code repository, and that relationship between the child and the parent is stored. So once you've passed here, all this stuff has been done successfully for the stage is passed, it just says who's the parent of this particular issue. Well, it's this particular feature version, which has objects that are in, in Bitbucket and in Jira and in Confluence. And then it pushes the code to the parent because it's defined it. So now we're back in the code repository, but here we're in the epic level. Once the code's been merged there, it automatically runs the correlating stage in the Jenkins pipeline, and when that's done, then it pushes code up to master, which then is hitting this Jenkins file and does some stuff. If it succeeds, it pushes it to staging. And at this point, when it's going into staging, it's creating the name for the Docker image, so that the Docker image is linked back through all this stuff because the name was created based on how it got there. And because you've reminded this image of its heritage by giving a name that tells us its ancestry, when it's going into staging, it's tracked directly to this conceptualization meeting that we had as people who are not business people at all, looking at a requirement and breaking that requirement down into issues. So, it's important. Earlier I showed you these three different elements of that go into a container, and one of them was app code. You know, we wanted to make sure that business people can access this, that operations people can think about this from an operations standpoint, and developers can think about this from the standpoint of, I'm a developer, but I want to see how what I do fits into everything and be able to talk to these other people. So sometimes we're going to talk about something as abstracted. So this is the most screamingly simple service ever that I'm telling you about here, because I want to show you how it all fits together. And each one of these levels was integrated by tools. So the developer, in order to implement this, really only needed to create 6 files. Our application goes into one place. If your application is very complicated, then you got 1,000 files here. But for our purposes, you know, you got a minimal app that's in code, but then you've got a Docker file, and the Docker file is going to define what your platform is. What are the things that are going to be included in the what runtimes are going to be included. And our requirements file, .txt file, tells you what dependencies are downloaded and put in there. And then there was this orchestration thing that's going to do Docker Swarm or Kubernetes. It's a different file, but that defines the virtual network of containers. Then the infrastructure gets defined in terms of a .tf file, and then our Jenkins file has our pipeline. So essentially what we've done here is we've taken 6 files and implemented everything that I described as these pie-in-the-sky things with 6 very simple files. Or if you want to say that this is our app code here, in addition to our app, we've added 5 files. This is not all that hard. It has complexity within each one of these, but you can abstract that out and see that this is not difficult to implement, because we're really, to implement all this pie-in-the-sky stuff I just showed you, all we have to do is add 5 files to our apps. So, what did the pipeline look like? Note here that I'm not putting numbers in these stages because they can be organized in different ways. The idea of this is to make it easier for people to think about it. You know, there was a stage to deploy the environment. That included creating the environment and configuring it. There was a stage to you know, deploy to test deploy the issue level code of the test environment. That included these different things: building the images, deploying the containers from the images to the test environment, running the tests, querying the next highest level, figuring out what that is, and then pushing code there. Then once the code's pushed up to the epic layer, you know, again, you check out the code, you build the images, you deploy the containers, you run the tests, that passes, and so code gets pushed up to master. And then in the master environment, you know, if there's no image in the Docker registry, we had some logic to check for that, checks out the code, builds the images, deploys the containers to test, runs the test, and now we're ready to graduate from our Git repository and push the code to the Docker registry. And then there was a stage to deploy the test environment, and again, that can go anywhere. Then you deploy the staging environment. We had things that happen, and you can destroy that. And it can deploy the production environment, deploy to it. And there are things like blue-green deployments where you decide that for this period of time you're going to create 2 redundant copies of your production environment. Once everything's up and fully tested and vetted, you route all the traffic to the new environment, and then you destroy the old one. That's why there's this destroy the production environment. So how did we create the infrastructure as code? Well, for this very screamingly simple example, we were able to do all of our infrastructure creation and destruction using one code file. That's this .tf file that can be called anything. We just call it Terraform plan for fun. And it set the target provider, which was AWS. It set a password, created a security group in AWS. It set the Amazon machine image to a correct operating system. It created a new instance with Chef as the provisioner. And it showed us a public IP address we were able to use. And once we built this very simple .tf file, we were able to write 2 words into the command line and have Jenkins actually implement these 2 words, Terraform apply. Well, it applies the plan and creates all these objects. So one of the things that happens here is if we're reducing the infrastructure to code, then our operations people can be producing our infrastructure code as a service to the development groups. Rather than maintaining all these networks themselves, they are producing software that does the environment creation for everybody on an automated basis. So our Jenkins pipeline runs this Terraform plan.tf, and it calls AWS. We've got a Chef cookbook floating around. It creates an EC2 instance that's one virtual machine, installs the Chef client, configures the Chef client to use the particular source of the cookbook, retrieves the cookbook, then runs the cookbook. And then it does it again with another EC2 instance, does the same type of stuff. And then we went into the DNS service, which again with Terraform, you can use any DNS service you want because it's all code. So you can use Route 53 with Amazon. There's also something called DNS Simple, which is something that you can deploy on any server, which does the same thing, but it's not dependent on Amazon. And you can mix and match these elements. So that was essentially, here's where we're going. This was as hard as our infrastructure was. There's one line of code that did several things, and all of a sudden we've got infrastructure, and we can run different parameters through that code file or collection of code files, and we create many different clones of it. So how did we use containers and container orchestration? Well, we had stages that included both a build and deploy, and in those it did things like assemble the files that we needed. Remember, we needed the application code, we needed the requirements list, we needed the Docker file. It built an image, and I'm putting code here because I want to make sure that we see this isn't that difficult. Here's the one line of code, Docker build -t and then the name of what we want it to build. And then it tagged these things and sent them to the repository by typing in a login command, a Docker tag image command, and a Docker push command. And the reason I'm pointing this out is to say it's not much code, it's not much learning. So then in all of the deploy stages, which is we're pushing to test or staging or production, all of these things, once the code's gotten to the registry, we created the swarm. And again, this is one line of code that goes into the Jenkins file. It's not that hard. Then we deployed the stack, again with a line of code. We ran the test. That's outside the scope of Docker, but that can be abstracted to a run test command. And then we took down the stack with, again, a very simple bit of code that needs to go in there. And then we took down the swarm. And this is essentially the code. So if you're not a developer, you don't have to freak out because this is as hard as it is at the high level. So if we're talking about having organizational change that implements all this stuff, we can get lots of people to see that there's simplicity in how it all fits together.